This is the battery holder for the AA batteries. I want to make sure you know how to put the AA batteries in. The AA batteries have a bump on one side, right here, and a flat side. The flat side is what goes to the spring. So they'll be, this actually makes the batteries wired up in series, but they have to be this way. You can't have them wired up in parallel with this setup, and that's fine. Make sure these wires don't touch. The red and the black should never touch each other. There. It's ready to go. Make sure they're all in there. And make sure that these two ends of the wires don't touch each other. You don't want batteries to short out. That's what would cause a short, cause a high current to go through it, and it's not good for the batteries. And if left for too long, they can get quite warm, and it's not a good thing. So don't do that. Never touch them. And I'll talk about how to make that safe on the circuit board in the next video. Okay, so I'm going to start wiring here. I have my battery pack and the wires coming from it. I have my proto board here. And as I stated in the handout, I'm going to put the red wire of the battery into right below the plus sign on the left-hand side of the proto board. And I'm going to put the black wire of the battery into the negative sign all the way over here. What that will do is allow me to connect anywhere along this column here is going to be the positive wire is attached to it. Anywhere along there. And anywhere along here, the negative wire is electrically connected to that. So I can plug a wire into here and into there and know that that's as if I took the red wire and moved it to here. So it gives me multiple ways to access power to any circuit that I construct. Let me give you an example. I'm going to take the resistor that's brown, black, red. It's this one right here. If you measure it with your meter, it'll come out to 1,000 ohms, or about 1 kilo ohm. And I'm going to attach that to the positive side of the battery right here. Okay, so I put the resistor in there, right there. And I'm going to attach it to a hole over here in the central portion somewhat arbitrarily. Now I want to connect something to that resistor, but I don't want to twist the wire together of the resistor and the LED. It's the LED. I want to get the LED to light up. I'm going to use the green LED. That's this one. I suggest you use that one right now too. And I'm going to take the the longer side of the green LED. If you look at it, one side is just slightly longer than the other. And on the video, I think it'll appear to you to be the upper side, but whichever side is longer, put that in the same row that the resistor is located. Push it in. And then the other side, which is the shorter side, can cross over the chasm that's in the middle there. Because these two sides, you may not be able to see it, but there's one lead and there's the other lead. These two sides are not connected because this chasm separates them. It's kind of like a moat. But this wire here is connected to that resistor there. That's what you measured last week with the multimeter. You verified that connection. Okay, then the only other thing I need to do to get this LED to light up is to attach a wire from here to the negative side over here. So I'm going to do that now. Attach a wire from here, from here to there. And there you go, it lit up. Because now I have a complete circuit. My current flows, I take my current is flowing out the positive side, down here through the resistor, through the light emitting diode, and then back down into the other side of the battery. Okay? The interesting thing about light emitting diodes, which makes them different, one of the things that differs from a light bulb, is if I plugged it in the other direction, it would not light up. It's plugged in right now, it won't light up. Diodes only let current flow in one direction. And that's something, they're kind of like solar panels in a way. Solar panels will force current to flow in one direction. Diodes will only allow current to flow in one direction. And if they're light emitting diodes, when the current is flowing in that direction, they will light up as you see here. This one happens to be with a greenish light. Okay, so that is the first portion of the lab, getting an LED to light up. Okay, so now I'm going to insert the switch. This is the switch. If you remember from last week, it has 3 little prong wires on the bottom of it. And I'm going to pull out the LED. And what I'm going to do is I'm going to insert the switch like this. So each of the little prongs is on a different row. One of the rows is going to be the row that the resistor has, the middle row in this case, the resistor is hooked up into. And actually, I'm going to move it over one more because I want to be able to access the hole on the other side of the switch. So I'm going to pull it out. Be careful, make sure it doesn't inject you when you pull it out. So I'm going to insert it like this into that column there so that each prong is in a different hole. The middle one is where the resistor is. And then on the other side, I'm going to put my light emitting diode, but I'm going to put it on the hole that the uppermost prong is on. So I'm going to put it one above where the resistor is. And I'll put the other lead in the same row that the black wire is in. So hopefully you can see it here. Now, why did I do this? Well, you'll see in a moment. What this allows me to do when I have it plugged in like this, if I push the switch up, notice that the LED turned on. Pull it down, the LED turns off. It's as simple as that, but you have to make sure everything's plugged in the proper hole for this to happen. When the switch is pushed in the upward position, there's basically a little wire that connects this hole right here to this one right above it. But when this is down, that wire connection is broken, and that's how a switch works. Okay. Now we're going to put in a second LED. First thing I'm going to do is I'm going to unplug the battery so that the circuit is off while we're working on it. It's a good practice in general, so that's what I'll do even if it's safe to work on it with the power on. I think it's a good idea generally to turn the power off. Then I'm going to take a second LED. I'm going to use another green one, and I will put the longer side into the hole that the bottommost tine of the switch is in the same row as. Okay, so it looks like this. The other lead of that LED is in this hole here. Now the problem is it's not connected to anything. I have to connect it to the ground, or I should say to the negative side of the battery. I call it the ground. Often you'll hear me doing that with another piece of wire. So I'm going to grab another piece of wire and I'm going to connect hard to see in here, but I'm going to connect that piece of wire to that same row that LED is on, also to the negative side of the battery. Okay, so now when I turn it on again, that light is on, but when I switch it, that light goes on. Switch it back to that light. You could do a little flashing sort of thing here. It's kind of fun. And just for completeness, go ahead and measure the resistance across both the on and the off LED. Not the resistance, I'm sorry, the voltage across both the LED that's on and the one that's off. It's good to practice this. And I'll do it both when it's switched on that way and switched on the other way. And see if it's what you might expect it to be based upon what you've already measured. The red one should actually be on this side. There we go. That would be the way to do it. Okay. Okay, this is the circuit you have thus far. For this part of the lab, we're going to set up the other two switches and the two red LEDs. So to do that, I'll start with one. I'll just do one of them, and then I'll do the other one. So I'm going to put the switch in just like I put the other one in. put all 3 tines in there. And like I said in the write-up, or what I wrote in the write-up, I need to have 2 of these resistors here, these 1 kilo ohm resistors, instead of just 1 here. I'm going to put 2 in series. I'm going to show you how I'm going to do that. So one is going to come straight out from this red power strip. Think of that as like a power strip where it's accessible. So I can plug in whatever I want to it, and I plugged in this resistor. And then I want to put another resistor in series. So to put another resistor of the same size in series, what I'm going to do is I'm going to pop it into another hole on that same row. So be careful of, try to make sure the leads are as straight as possible on the resistors. They're a little flimsy, and so they can bend, and then they're harder to get into the holes. And then your circuit won't work if the lead isn't in far enough. So that's just one thing you'll need to check if things aren't working. And then this lead of this resistor is going to go in the center of the switch, the center tine of the switch, which I believe is that hole right there. That's connected to the center tine of the switch. Okay, so I have my 2 resistors here that are in series. They're in series because the current is going to go from this one through that one. It's going to pass from this hole to the other hole on the same row, because there's just a piece of wire there. Then it's going to pass through the other resistor, and then into the center tine of the switch. From there, it's going to pass into, I'm going to put the LED in the on the upper tine of the switch, which is this one. Or I'm going to put it in a hole that's connected to the upper tine of the switch, I should say. And that has to be the longer lead of the LED. Okay, and then I'm going to put the other lead across the chasm and onto the other side. So you can see that there. So this LED right here is feeding into that hole there, which is the upper tine of the switch. So when the switch is in the upmost position, that LED should turn on. The only other thing I need to do is I need to tie this end of the LED to the negative side of the battery. So I need another piece of wire that goes from there to there. And I have one here that seems to be just about the right length. I have to put it in the same row. Whoop. So push it into that hole. That's in this, there we go, it's in. And I'm going to put it in the farthest right column. Any hole will do. Whatever one is best fit for that wire. Be the one there we go. I got it in there. All right. Now I'm going to turn on my circuit and just see if I got this light to light. And then I'll do the same thing one more time. Okay, there's this one. So this one still works as it should. This one dimly lights, interesting. It's definitely lit. You can see it. It's not as bright as the other one, but it's lighting up. Okay, one more to go. Okay, I'm going to do the final switch and LED configuration, and then we can do some measurements with the multimeter. First, I'm going to turn off my power supply so that I'm not working on a hot circuit. Although, like I said, there's no safety issue here, but it's just good practice in general. I'm going to put my other switch in. I'm going to pick 3 holes to stick those 3 tines into. There we go. All right, so that switch is in. I'm going to do the same thing. I'm going to put a resistor, 2 resistors in series, as I said, for the red LED. Although that's probably why it's so dim. But I was just afraid that if I put just one resistor, that may not be enough. And I already burned out a couple of my LEDs. I don't want you to burn out yours. Although they're relatively cheap, it's just an issue of getting one then. Okay, so I have one resistor going from this terminal right here to that hole right there. So I'm going to put another resistor in a hole near it. Or I'm sorry, in a hole that's on the same row, which is near it. And then I'm going to run that resistor, I'm going to put it into the center tine of the switch, or into a hole that's connected to the center tine of the switch. All right, so when the switch moves up, it'll connect the resistor to the upper tine. When the switch is down, it'll connect this lead of the resistor to the lower tine. So I can put my LED in either spot. So my other red LED I'll put right here. Oops, I think I missed the right hole. I think that's the right hole. If the LED stays on, no matter what the switch position is, then I put the LED's lead into the wrong hole. I put it in the center tine of the switch, and that's not what I want. I want it on either this end or that end, not in the center. All right. Now I'm going to add the little piece of wire that will bring it to the negative of the battery, which, as I said earlier, is often called the ground. So you might hear me calling it the ground if I forget that I haven't explained that yet, but it's to the negative side of the battery. Let's see if I can get that in. A little screwdriver or something could come in handy to push it in, or a little pair of pliers maybe, but I'm using my fingers, doing the best I can to get that little piece of wire in. There we go, got it in. Okay, so there's my setup. Now I'm gonna put my battery back in there, and it's almost time for my Christmas lights. There we go. And here's one I can switch. Here's one I can turn on if it's up. This one is already on because it's in the lower position, so if I turn it up, it goes off. All right, so there's my switching arrangement. And now I can measure it with a meter. One thing I realized about the meter is, even though it has the 1.5 volt battery set, let me move this over to here. Even though the meter has the 1.5 volt battery setting and the 9 volt battery setting, you don't need either of those. Matter of fact, it's better not to. I don't even like those settings. I didn't realize. It has the other voltages over here. Just use those. Probably leave it on the 20 volt setting because you're never going to measure anything more than 20 volts here, but you will measure things more than 2 volts. So the 20 volt setting is perfect. So you can just use that. It's a lot like what other folks are going to have. And then you can make whatever measurements you need to make of your circuit here. So when this LED is on, let's see what its voltage is. Looks like it's about 1.6 volts. You can't really see it, but you'll see it on yours, hopefully. All right, yeah, about 1.61 volts, and I can measure the voltage across either or both of the resistors. Let's see. That one looks like 4.67 volts. Oh, you know what? I used the wrong resistor in there. That's what's going on. That's why these LEDs are so dim. I used the 47 kilo ohm resistor. I didn't use brown, black, red. Yours will look a lot better than mine just did. So I'll show you just for kicks. I'll put the proper resistor in there. It's hard for me to see these colors. Yeah, this is the proper one. So watch how much brighter this resistor is. So please do use the two 1 kilo ohm resistors. You got to see me make a mistake, and my light was much dimmer because the resistance was so much higher. Let's see if this helps. Oh, it's in the wrong hole. There we go. A lot brighter that time, huh? So different resistors make circuit elements respond differently. And you'll see a much brighter resistor too. So if you make the measurements now of the voltages, they'll be different than they were earlier. This one now looks like about 1.88 volts, and it's brighter, so the voltage across it is bigger. It's drawing more power. This resistor is 2.21. This one should be close to that 2.19. The sum of those, think about what that should be. All right, that's all you need to do in this lab. You're welcome to play with this, but and adjust your switches to do some other fancy things that you might find interesting. Just avoid short-circuiting your batteries per the earlier discussion. Okay, enjoy. One final note, when you're storing your battery holder, please pull out one of the batteries in it, because if these two wires touch when it's in a box or wherever, these batteries could get hot and they could also be damaged. And I wouldn't want either one of those things to happen. So pull out any one of these, and if they touch, that won't be an issue. Okay.